welcome to this tutorial. My name is Afiki Lesikwebu. I will be doing a few tutorials on the Arduino. I am based in South Africa, and South Africa is the country right at the bottom of Africa. And in South Africa, I am right about here, not Cape Town, just somewhere there. So yeah, I like to play with toys and I like to take toys apart. So welcome to this tutorial, as I said, and this tutorial will be introducing you to an Arduino. And an Arduino is basically a microcontroller, but I will explain that. And just to maybe, if I can say just a few things, this tutorial expected to be as basic as it can be. I am going to speak in the simplest form. I will try as much as I can to not be technical as much as possible. I will use terms that you can relate with. And so if there's anyone who's watching this video who is going to be cringing as I am explaining, please forgive me ahead of time. I will not use technical terms at all so that we do not lose anyone in terms of we don't get anyone confused. So the platform we are going to use today is Tinkercad, and I will leave a link on the description, and I will leave a link of some few places in Port Elizabeth where we are, where you can buy some components. Yeah, if you've got any questions, you can leave the questions on the link, well, on the comment section. So Tinkercad is the software we are going to use. It's an online platform, and it says that it is a free, easy to use app for 3D design for electronics, which we are going to be focused on, for coding, and it's used by teachers, kids, hobbyists, and designers to imagine, design, and make anything. And these two components we are going to look at in this our tutorials, and we are going to be looking at electronics and coding. You can go on and just read up on 3D design, electronics, and code blocks. You can watch this video that they supplied, and basically you can look at what other features that they have to offer us. As we begin, before I even start explaining what an Arduino is, I want us to look at how we access the platform. As I said, I will leave the link on the description below, and tinkercad.com is what we are going to. And we either will sign in or we will join. I want to assume that we don't yet have an account, so we are going to join Tinkercad, and we have two options. We are either a student or an educator, then not two choices. Well, we have three choices: student or educator, and you can choose to then use your personal account to create an account with Tinkercad. So I will choose create a personal account, assuming that you don't have one. Then you will be asked for your email to sign up with email. You can sign in with Google, you can sign in with Microsoft, but I'm choosing to sign in with Facebook. And it's going to then ask for access to your Facebook account, or rather to your Facebook details. And I will continue with this Facebook account. Then it's going to go back, it's going to communicate with Facebook, and Facebook is then going to say, yes, we know this person, and it's going to give Tinkercad access to my account. And therefore, you will see that it's going to give me my account, which I have previously created. So this profile picture, for instance, doesn't have anything to do with Facebook. It's a profile picture that I selected when I joined Tinkercad. So if I click on it, it will then bring me to my profile. I can then put my name, I can put my email address, and a little bit about myself, which I am not going to do at this point in time. And if I want to change this picture, I can click on choose picture, and I choose the picture that I want, and I then save. It will then give me a new profile picture. And if I come to this, you can then also look at kids activities, and you can have an invitation code, which we are not going to do tonight. And then so if I come to now to this logo of theirs here, it will take me back to my profile. And if we look at the left panel, which is on the left of the screen, we have 3D after my name. Below my name, we have 3D designs. If you wanted to do 3D designs, you can look at 3D designs. You can also you also do circuits, which is what the purpose for the video is all about. We are going to do circuits, but you also have lessons and code blocks, which you can look at in your free time. And so we are going to choose circuits because that is what we are all here to do. And this is something that I had done before, so I can delete that. And if I wanted to open a sketch that was here, let's say this was a sketch that was here. There is nothing here. I think this is a sketch that is a standard sketch, but we don't want to do this, so I'm going to delete this one as well because I don't need it. But all the sketches that you have created in the past, they will all be listed here. And so you can either create a new, let's create a new circuit for the purpose of this video. And so while it loads, we are going to, as I said, the video is basically about an Arduino, and I want us to select an Arduino because that is what we want to look at. So I would like to select one Arduino, which is let's take this one. Okay, sorry, there it is. Let's take this one, and I just want to delete these components because we are not going to use them now. So we have now this Arduino. So if I can just read from SparkFun, what the website sparkfun.com, what they say an Arduino is. So they say an Arduino is an open source platform used for building electronics projects. It consists of both a physical programmable circuit, which is this guy here, and a programmable circuit board, okay, which is called a microcontroller, which is this entire thing that you see here, and a piece of software or IDE. So it will come with an IDE with a software such as this one, IDE. It is now coming up. This would be when you have an Arduino, a physical Arduino. But because we don't have a physical Arduino, we are going to use the built-in IDE, which is this one. But we are not going to use blocks. We are going to use text only. So this would be the IDE. So if you look at it, it is quite similar to this IDE that is a standalone program. So this is how it is when it starts up, and then you can write your code in there according to what you want to do. So this is our IDE. This is the code that we found here. This is what it's supposed to be like when it starts out. And so this is your Arduino now. So they've said that it's an open source platform, and we use it to build electrical projects. One of the things that I like to do with my Arduinos is that I like to break up toy cars. Those, you know, the remote controlled cars. I like to break them up, and I put an Arduino inside it, and then I can basically write code that will control the car, the electric car. If I want to turn into if I want the car to turn left or turn right, if I want it to reverse or go forward, I can also put in sensors. I can put distance sensors that it must stop when it senses that there's something in front of it. I can also put other things like lights, and there's quite a lot of things that I can do with it. You can control lights. You can control the physical environment with your Arduino. So there's the nice thing also about it is that there's quite a lot of people who use Arduinos. There's thousands and thousands of people who use Arduinos. So if you get stuck, there is Arduino.cc, their website. It has a forum there where people discuss different things. So you can Arduino.cc. You can go there, and there's a forum here with people that just basically, if you get stuck, they give out advice, and there's other discussions that take place. If you get stuck, you can ask your question, and there are people who are very willing to help. I mean, if you look at General Electronics, for instance, there's 260,000 posts and 25,667 topics just on general electronics only. Yeah, this one, programming questions, there's 821,519 posts. So as you can see, there is a lot that you can get out of their community. So that is a platform, that is a place you can go to if you get stuck. So then the other thing is that you then have this section here, where you can either code, and then you can, I think I've briefly explained this, and I hope I had said that I'm going to be as non-technical as possible, so I will use very simple terms to explain, and you can then start the simulation. So once you have written the code here, let's say you wrote a code. I'm going to write a very simple code to, let's say we had a red light here, and we made it like that, and it's very simple. I will explain just now. And so let's say we wanted this code to switch on a light bulb, right? For 1 second, and then it switch after 1 second. It must switch it off. It must then switch it off after 1 second. So we would then use this to write our code. So now it will then, if we start simulation, if we had a light bulb connected here to the Arduino and we start simulation, it will then follow our code here, right? It will then follow our code, and it will interpret the code and tell the light bulb what to do. So you will see that it's given me an error, and I fixed the error, and it would then, if you say start simulation, you will see now it's basically switching the light bulb on for 1 second and switching it off for 1 second. So we stop the simulation. You can export the code. You can share the code with other people who can come and mess around with your code also. And you can also download your code to use in your IDE on your laptop. And so that is what we can do here. So what we also have is that we have a library of components, right? You can choose resistors, LEDs, potentiometers. You can have buttons, capacitors. You have quite a big library of components. You know, if you wanted to use an ultrasonic sensor, you would choose an ultrasonic sensor. An IR sensor, you can choose this one. So there's quite a lot of there's a huge library of things that you can do. But this video, as I said, is just introduction. So if you look at the Arduino itself, you will see that there's pins here from 0 to 13, and you will see there's pins here, analog, there's digital pins, and then there's analog pins, 0 to 5, and then 0 to 13 on the digital side. And you will also see that it has PWM and that squiggly line, and you will see there's a squiggly line for 11, 10, 9, 6, 5, 3, and we're not going to really explain that tonight, but that line, it basically tells us that these act like digital pins, but they can also be used as PWM, which we are not going to talk about now. I can send you to other channels where you can learn about that. So these ones, if I can speak in a very simple way, if you look at your light switch at home, to switch it on, you press the switch. To switch it off, you press the switch again. So there are two states. There's two states, on and off. So the states here are basically on and off. You switch it on and you switch it off. It is either on or it is off. That is your digital pins. And then your analog pins, A0 to A5, there's 6 of them. It is it's the pins here, they can read signals from, for instance, from an analog sensor. Maybe you have a temperature sensor. They can read the signal from that, and then they convert that into a digital value that we can also read. If I can give a simpler example, let's assume you have lights at home, the dimming lights, the lights that you can dim. If maybe you don't have an idea of what I'm talking about, let's say we have lights that we can dim. If we can maybe just look at this random video that I've just found. While it loads. Okay, so let's hope it's actually going to dim the lights. Okay, so now you see they are getting the light gets darker. The light gets darker and then it gets brighter. Okay, well, it was a poor video for the purpose of my explanation, but basically you can make your light brighter or dimmer. And what happens is that you can use then these pins, because you can choose values between set numbers. Here you can also choose between on and off. It can either be on or it is off. Here you can choose between different values. So you can choose to make it brighter or dimmer, depending on what value you have chosen. And I'm going to try and run away from being technical. So you can choose values here and use them however you want to use them. And then we also have a VIN. VIN we are going to skip for tonight. IOREF, we are going to skip this reference for tonight. The reference also, the reset we are going to skip. There's a ref we are going to skip. So we have ground. We have 3 grounds. So it says 2 on this side and there's 1 on the other side. And basically, what I would use your ground for is to complete your circuit. You have a circuit, and it's connected to the positive, and it goes all the way to the battery. And to complete your circuit, you have a ground. If your ground is at 0, then your circuit is off. If your ground is at say 1, then your circuit is on. So it's your on and off. Then you have two more grounds on this side, and then your Arduino can supply between 3.3 volts and 5 volts. So itself it receives 5.5 volts power, I think, and then it can give out 3.3 volts, and it can also give out 5 volts to the connected devices. And yeah, if I think I've come to the end of tonight's lesson. And basically what we looked at the fact that an Arduino is a microcontroller, and it is used to control devices that are connected to it. We can connect multiple devices to an Arduino, and we can make those devices work. I said an example is that we can connect a toy car to our Arduino, and we can make it move around and navigate its way around the room if we have sensors connected to it. We said also we have digital pins which we use to connect the devices into the Arduino, and these pins are used by the Arduino to communicate to that device that we have connected to it. And we have two states. Maybe I didn't explain this one. We can either read or we can write. So we can bring in information from outside, which we are reading, and we can also write into the Arduino, or we can also write that information out to the component. So the Arduino is telling the component what to do, and sometimes we are bringing something into the Arduino so that it can process it, and to maybe say, let's say there's a calculation that it must do based on what we have told it. So yeah, I hope that it was a clear explanation, and if you have any questions, please feel free to ask them on the comments section. Until next time, thank you very much.